In this video, we want to take a look at using linear equations in one variable to solve word problems or application problems. Now, you may have seen this strategy before, but I want you to really think about it. In my experience, students often struggle with word problems because they're not stopping to read the problem carefully and making sure they really understand it and can explain it to someone else. If we know what's going on in the problem, that often leads us to the solution, or at least how to find the solution. So let's go through the steps. First, read the problem carefully. You want to read it over and over until you really understand it. You want to get to the point where you could explain it in your own words to someone else. Tell them, hey, here's what we know, here's what we want to know, that kind of thing. If there's a question that's asked or a directive that's given, normally at the end of the problem, let that be your variable. So, what was the length of time? Well, X is the length of time, that kind of thing. Second, you want to try to come up with an expression that translates the English words into algebra. We're going to look at some key words in just a moment. Step 3 is, okay, now we've got expressions. Let's try to come up with an actual equation that includes that variable that we used at the beginning. Finally, we'll solve the algebraic equation and then check it to make sure it makes sense in the original wording of the problem. Let's take a look at those key translation phrases, right? So adding, subtracting, multiplying, and dividing are the key operations that we use in algebra. And some words that might indicate that I'm using addition are sum, more than, increased by, greater than, those sorts of things. For subtraction, I might see minus, decreased, subtracted from, difference, that is a big one. Anytime you hear the word difference, you want to think about subtraction. Less than, fewer than. The tricky part about subtraction is that order really does matter. So we'll see that in one of our examples. Multiplication. Some words that might indicate we're going to be multiplying would be times, product, percent of, that is the key word, the of, multiplied by, obviously, twice, 3 times, 4 times, that sort of thing. And lastly, division. There aren't so many for this one, but divided by, obviously, the fancy word quotient or reciprocal. That means you're going to be doing some division. All right, let's take a look at a few basic problems then. So it says when 2 times a number is decreased by 3, the result is 11. What is the number? All right, so I'm taking a number, multiplying it, decreasing it, and getting an answer. That's the situation. So I understand the problem. I also know what I'm asked to find, and that is that original number. So remember from our strategy that whatever that directive is, that kind of clues me in as to what to make the variable. So in this problem, I'm going to say x. Oh, that's a terrible x. Let me try that again. Sorry. Get a different one. I think I clicked the wrong thing. There we go. Let's let x be the number. All right, so x is my number. Now I'm going to read this again and try to translate using those key phrases. 2 times a number, well, my number is x, times means multiply, so I would say 2x, 2 times a number, is decreased by, so I'm subtracting from that. How much? It says by 3 is decreased by 3. Result is, so answer equals, that means equals 11. Now I have a basic algebra equation and I solved using my steps. First, I'm going to isolate my variable and then I'm going to get the term with the variable, that is, and then I'm going to get the variable itself by itself. So I'll divide through by 2. And I'm going to get my final answer here of x equals 7. Now let me see if that works. So when 2 times a number is decreased by 3, so 2 times 7 would be 14, decreased, subtract 3, Yeah, that'd be 11. So this checks. All right, let's take a look at another one. So in this problem, I have 80% of a number is added to the number. The result is 252. What is the number? Well, just like the last one, that question at the end tells me what my variable is, but I'm going to be very explicit and say x equals the number. Okay, now 80% of. I can't use that percent symbol in an equation. I have to convert that to a decimal form. So percent means per 100, so we're going to move the decimal point 2 places. So 80% is equal to, if I move the decimal from where it is, 80, so the decimal is after the 0, 2 places, my answer here would be it's equal to 0.80, right? Okay, so 80% of a number. So I'm multiplying that times my number, and it's added to the number. Okay, so 80% of the number, that's 0.80 times my x, my number, added to, adding the number. What was my number? Well, that's where I've got my side note here. X is the number. So 0.80x plus x, result, so equals 252. There is a number in front of that plain x. It's a 1. And a 1 plus point anything is 1 point whatever. So this next line would simplify that and make it 1.80x equals 252. And then I would get my trusted calculator here and say, okay, if I'm going to divide, well, pull it up, there we go. 252 divided by 1.8 or 1.80, either one will give me the same. It's going to tell me 140. So again, I'm going to divide both sides by the 1.80 and come up with my final answer of x equals 140. So it says 80% of the number is added to the number. I could check it, clear this out. So 80%, 0.80 times my 140, what I think my answer is, added back to 140, my number, and sure enough, the result is 252. I have a couple more. This next one says one number exceeds another by 24. The sum of the numbers is 58. What are the numbers? Okay, so I have a little bit of an issue here. I'm asked to find two different numbers, but we've only been working with equations in one variable. So I'm going to just let x be one number. How do I find the second number? Well, I go back to this first phrase here, or first sentence. It exceeds another by 24. So it's 24 more than the other number. So I would say x minus 24, because my first one exceeded the second one. So x minus the 24 would be the second number. Okay. All right. So if one number exceeds, it's more than. So to get to that second number, I'd have to subtract. Now, it says the sum of the numbers. The sum of the numbers means I'm adding the two things. What are my two things? This one and this one. So I'm going to add x, and I'm going to just put it in parentheses for emphasis, x minus 24. So first number times second. First number plus second number, and it is or equals 58. Now to remove those parentheses, nothing's going to really change because there's just a 1 in front of the parenthesis. So x plus x would be 2x minus the 24 equals 58. So normal solution techniques here, we're going to add the 24 to both sides and simplify. So 2x is going to equal, what's that going to equal? 82. And then we're going to divide to get x by itself. and determine that x is equal to 41. Okay, so what's x? X is one number. So I'm going to put that back up here and say one number is 41. How do I get the second number? I follow the pattern, which says x minus the 24. So 41 minus 24. So my second number would be 17. Right? So one number exceeds the other by 24. Yes, there's 24 difference between these two numbers. And the sum of the numbers, if I added these up, would be 58. So we've got the correct solution. One last problem. All right, the length of a poster is twice the width. Now, hang on one second. Okay, had to clear my shade there. So the length of the poster is twice the width. Length of a poster is twice the width. Well, I know posters are normally kind of rectangles. Okay, I know it's a little wobbly, but let's go with it. So the length is twice the width. Again, I'm only allowed to use one variable. So which one should it be? Well, the length is given in terms of the width. So the width is like my standard. So if I let the width, I'll make both of those W because they're going to be the same. I'll let the width be W. Then the length is twice that. So twice means 2 times. So the length, the other side, would be 2W. And again, the two lengths are going to be the same. Then it says the perimeter. Well, if you remember from geometry, perimeter means the total sum of all the sides. So I'm going to go around. Now, for a rectangle, there is a formula, but if you don't remember the formula, it's okay. Perimeter just means the sum of all the sides. So if I start at the top, I would say W plus 2W plus the W at the bottom plus the 2W on the other side. That's adding up all the sides, needs to equal 48. Okay, 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 2 is 6W equals 48. Dividing both sides through by 6, we would get W equals 8. Okay, again, what have we found? Well, what we found is W, and according to my picture, which is why I love pictures, that means that the width is plain W, 8 inches, and the length is 2 times that, so 16 inches. What are the dimensions? The dimensions, length and width, is going to be an 8-inch by 16. Oops, I didn't write that correctly. Let me try that again. An 8-inch by 16-inch poster. Let me know if you have any questions.